In this demo, we are going to reintroduce the kubectl run command, and via that command, we are going to introduce the deployment object. Recall that deployment objects are a higher level abstraction which encapsulate within them a replica set, which in turn has a pod template. As usual, let's start by listing out all of the pods in our cluster just so we know where we stand at the start of the demo. Here, we are starting with a completely empty cluster. There are no pods in existence at this point. We already have experimented with a kubectl run command, which has the effect of firing off a deployment with a single pod within it. Let's come back to this command. This time we will examine it a little more closely and ascertain for ourselves that it has within it a whole replica set. In any case, the result of running this kubectl run command is to create a deployment called example. The image which we would like hosted within the pods in this deployment is the Nginx pod. As we discussed in one of our early demos, there are several powerful switches which we can pass into the kubectl run command, notably the number of replicas. Here, because we have omitted specifying that, the number of replicas is set to 1. So if we follow up this with a kubectl get pods command, we see just the one pod in existence. This pod has just one container within it, and that one container is ready to accept client requests. Let's take a look at the detailed state of this pod by using the kubectl describe pod command followed by the name of the pod. That name of the pod was something which we copy pasted from the output of kubectl get pods. Let's check out all of the state of the object which is returned by Kubernetes. We can see that there is the pod name, the default namespace which it belongs to, the node, which here is an underlying Google Compute Engine VM instance on which this pod is hosted, the start time of the pod, the labels associated with the pod, annotations, status, IP, and last and maybe most interesting, the controlled by field. Notice that that controlled by field specifies a replica set, even though we have not created any replica set so far. This is a clue, this is a telltale sign that a replica set has been created when the deployment object was created. This replica set is tightly coupled with and encapsulated within the deployment object. And there's another interesting bit in the metadata on screen. Notice that our pod is marked with two labels. The first of these is pod template hash, and the second of these is run, which has the value of example. It is these labels which set up the coupling between the pod and the deployment object with the name example. When we invoke the kubectl run command, we had specified that the name of our deployment was going to be example and the image was going to be Nginx. And both of those pieces of information are indeed present in the status which is output to screen. Like with the other objects we have worked with so far, we can list out all of the deployment objects using the kubectl get command. Here we run kubectl get deployments and we just get the one deployment which is named example. We can also see that the desired number of pods which is equal to the current number of pods, which in turn is equal to 1. Now, a moment ago, we had run the kubectl describe command on the one pod within this deployment. Let's go ahead and run kubectl describe on the deployment as a whole. And right away, we notice something interesting. We can see that this deployment also has the label run equal to example and the image equal to Nginx. In other words, the information in our pod object has to exactly match with the information in the governing deployments label. If we look carefully at the description of our deployment object, we can also see that it has a replica set associated with it. In fact, deployment objects can have a large number of replica sets associated with each individual deployment. As we shall see, this has to do with the manner in which new replica sets are created as deployments revisions happen. Here, so far, we only have the one replica set in existence, and that's why in the description, that's all that we see. This is in the field titled New Replica Sets. As usual, let's satisfy ourselves that this pod actually runs. One way in which to do so is to set up an interactive shell, which is in the live container within that pod. As before, we are going to make use of the kubectl exec -it command. This will have the effect of opening up a bash shell inside our container. Note that we are running as the root, so there's no need for us to preface any command with the keyword sudo. Let's go ahead and echo to screen a message hello nginx, and let's pipe this into our index.html file. This file is going to be what's served up when a user hits port 80 of this container. Next, let's go ahead and update our apt-get. This is merely a prelude to installing curl. And once the curl utility has indeed been set up, we can go ahead and hit curl localhost. Along the way, we will be prompted for additional disk space. Remember that we are running this on the cloud, so increasing the amount of space associated with our Kubernetes cluster is going to also add to our Google Cloud bill. We hit yes and we keep going, and eventually the download of curl is going to be complete. Once that's done, we go ahead and hit curl localhost. That in turn causes the same message which we had typed out to screen, which was hello nginx. This is all that we need to demonstrate that our pod and our container within it are indeed successfully set up.